Welcome back, everyone. In this lecture, we're going to discuss how to work with missing data. Real-world datasets often have missing data. Realistically speaking, there are really only three ways to deal with missing data. The first is to just leave it as missing. Second is to remove the missing data. And third is to fill in the missing data. Let's briefly discuss each of these strategies. The first strategy is to just leave in the missing data as missing. And depending on the type of data, this is often a valid choice. For example, if you're dealing with categorical data, such as the colors of houses, and for some reason you have some missing values there, if there's not that many missing values, you could simply just treat in the not a number or missing data as another category. You could use your Pandas skills to later on replace it as a string, maybe saying not a color or not present. For categorical data, that's a perfectly valid choice. Again, it really depends on the situation. The second option is to remove the missing data. Whether or not this is a valid choice really depends on the situation, the overall goal, and also it strongly depends on how much data is missing. Let's think of it in the context of a feature column in our data set. If we're missing a large percentage of this column, for example, let's imagine that we're missing 95% of all the values for this particular feature column, then we're missing too much to actually make a reasonable guess as to what those values should be. So we should probably just drop that column to begin with. However, let's imagine we're dealing with a small percentage. So again, thinking of that feature column, if we're only missing a few points off of that, then it probably makes sense to just remove those rows that correspond to those missing points on that particular column. So again, if you have a large percentage missing from a feature column, go ahead and just remove that column. There's not enough useful information there. If you're only missing a few or a small percentage of values there, go ahead and drop those corresponding rows. You're probably not going to lose that much information from those extra data points. Finally, and this is usually the hardest to figure out, is filling in the missing data. So this is where you have a non-trivial percentage is missing, and also maybe the data point rows are really important, or you don't have enough data to comfortably just drop data points. There's lots of strategies available here. Often, people fill in missing data with things like the mode, the mean, or the median, or they base it off another feature column and conceive of a reasonable value. Keep in mind, there is absolutely no correct answer as to what the approach should be to fill in missing data, because at the end of the day, you're just making an educated estimate or guess as to what that missing data should be. Because by definition, you are to some degree making it up. Maybe you're making it up based off a very sophisticated and smart model, but you are still conceiving of something that wasn't actually there. So filling in missing data is the hardest one to do, but it's often the one that allows you to keep all your data, which is also a nice trade-off. Now, a really common student question I get is, what is the correct approach to actually dealing with missing data? And unfortunately, the best I can say is all data sets and situations are completely different. So there's not a general consensus answer I can give here. What you should do is use your common sense, and more importantly, think of the overall goals that you're trying to achieve when you're dealing with this data set and machine learning in general, to see which strategy makes sense. If you have millions of rows, then it's probably not a big deal to actually just remove some of those rows in order to get rid of that missing data. If you have a really small data set, you're probably going to want to try to figure out how to fill in those missing values or how to be smart about it in order to leave the missing values in. Okay, let's go ahead and see what options Pandas gives us for each of these strategies. I'm going to head over to the Jupyter Notebook. Here I am at the Jupyter Notebook. I've gone ahead and imported NumPy as NP and Pandas as PD. Then I opened up our missing data notebook and I copied and pasted the contents of one of the very first cells here in order to create a data frame that already has some built-in missing values. So here, if I actually call the data frame, and again you can copy and paste this code from the notebooks we provide, I can see I have three columns A, B, and C. And the important thing to note here is that only one of these columns, column C, still retains all its values, 10, 20, 30, and 40. And rows 0 and rows 3 have all their values, 1, 5, and 10, and then 4, 8, and 40. The rest of them, we can see here, have some sort of amount of missing data points. Now let's recall our three strategies again. Strategy number 1 is to simply just leave the missing data. So in that case, we're pretty much already done. So we'll move on to strategy 2, which is removing the missing data. Now there's various parameters we can use for this. The main method call is df.drop NA. And we can see here that if we do Shift-Tab, the documentation docstring has axes, how, and threshold as the main parameters. It also has a subset. So you can see here what the different parameters stand for. Axes determines whether you're dropping this based off the index or columns. How determines if you're going to do it if any values are missing or if all values are missing. Then there's also a threshold, which requires that many non-NA values. And then there's also a subset, labels to consider along an axis. So if you're dropping rows, these would be the list of columns to include. Now, typically what we're going to do is drop based off columns, but if we just run df.drop_na, by default the axis is 0, so it's going to be looking at rows. So it's only going to return back the rows where nothing is missing. If I say axis equal to 1, then it's just going to return back the column where nothing is missing. I can also specify a threshold. So I could do something like, say, thresh is equal to 2, which actually brings back everything. So recall that threshold means it requires that many non-null values. So it must have at least 2 non-null values. And all of these columns actually have that. Column B has at least 2 non-null values. But let's imagine our threshold was 3. In that case, column B no longer applies since it only had 2 non-null values. And often what people do is they base this threshold off some sort of percentage. So maybe we can see here we want at least 25% of the values to be non-null, or something similar to that. We could just calculate that based off the length of the data frame, and then maybe we say something like 0.25, or something of that nature. Okay, so we can see here that we were able to drop based off the rows or the columns, and also set off thresholds, as well as say things like how, like any, or all. The third strategy we discussed was to actually fill in the missing data. To do that, we can say df.fillNA. And this is actually very flexible. Again, it has parameters such as values, methods, axes, in place, etc. But the main way we can see it here is by saying value is equal to, and then just passing in fill value. Before I run this, I want to show you what the original data frame looked like. So recall our original data frame here has these 3 missing values. Recall also that technically the data types, if we were to look at them here, are floats and integers. However, I'm passing in a string as my fill value. So what's kind of interesting is Pandas doesn't complain. It just says, okay, if that's what you want, that's what you can get, and it went ahead and filled in those values. So we can do this with essentially anything we want. We can say df fill value and say go ahead and make any missing points equal to 0, and there we have zeros. And it's going to try its best to make sure that if you just said an integer 0 here, but these were floating points, it converts it to floating points. Similarly, it converted 5 and 8 here to strings in order for these fill values to actually match. Okay, so the other thing to note here is I don't have to do this across the entire data frame. If I want, I can do this based off columns themselves. So I can say df of A, go ahead and fill in any missing values there as 0. And then I get this back. So I could technically then do some sort of reassignment, such as df of A is equal to df of A fill in, and that now has actually permanently affected my data frame so that that missing value has now been filled in with 0. However, let's imagine I wanted to do something maybe a little more clever. So I wanted to fill in, for example, the missing values in B with the average value across B. What I could do is say dfb, go ahead and grab the mean there. Note it's 6.5, so it's essentially halfway between 5 and 8. So what we're going to do then is say, okay, take dfb and then fill NA, where the value to fill is equal to dfb.mean. And this is also a really common strategy. And I could technically do this across an entire data frame by saying df fill NA with df mean. And notice here it fills it in with 6.5s as well. Okay, and it would do that for any column that happened to be missing information. So if I were to essentially rerun this to get back that a missing value here, and I said df fill NA with df mean, run that, we can see here it fills it in with the mean of 1, 2, and 4, which happens to be 2.33 for that column. Then for column B, it does it with 6.5. So it does it on a per column basis, which is quite nice. All right, So that's it for the 3 strategies of dealing with missing data with pandas. Thanks, and I'll see you at the next lecture.